Hey guys, so today we're going to focus on the topic of coordinate geometry. Okay, so this topic is pretty simple and I'm pretty sure most of you are familiar with it. So let's get right into it. So, firstly, this is a graph here. We have a y against x, right? So let the first point on this graph here be A, and let this point here be B. We'll give this the coordinates x2, y2. Remember, for graphs, you always give the x coordinate first and then the y coordinate, right? So we'll let this be x1, y1. Okay, so the gradient of a line, I'm pretty sure most of you all are familiar with it. The gradient of a line is given by is equal to y2 minus y1 all over x2 minus x1, right? So basically, this is also equal to delta y, which is a change in y, over delta x, which is a change in x, right? The gradient is also given by the symbol m, okay? So, for example, let's say we have coordinates 1, 4, and 4, 8, okay? So therefore, the gradient between these 2 points, the gradient of the line connecting these 2 points would be y2. So let this here be y2. So it'll be 8 minus 4 all over 4 minus 1, which is equal to 4 divided by 3. So this line has a gradient of 4 over 3. Now some things to note. Let's say, what if we had a graph? So let's say this is our y and this is our x, and we had a line here, right? This line, right, this line here would be given by the equation x is equal to c, where c is some constant value. For example, it could be x is equal to 5, it could be x is equal to 100, right? X always has a constant value. This type of line, for this one here, I just label this one A. For this one here, the gradient is equal to infinity, okay? This one has an infinite gradient. Suppose now we have a different case now. We have our x and y axes, but this time we have a line this way. So this line here is given by the equation y is equal to c. For example, it could be y is equal to 5, sorry, not x, y. Y is equal to 5 or y is equal to 100, right? So this horizontal line is given by y is equal to a constant, whereas a vertical line is given by x is equal to some constant. And the gradient of this line is equal to 0, because basically the gradient tells you how much y changes when x changes, okay? And what you can see here is as x increases, as x goes this way and it increases, the y value does not change. So therefore there is no change in y value. So therefore the gradient is 0. For this one here now, as you could see, there is an infinite change in gradient because it is a vertical line going straight up, okay? Also, one more thing to note about gradient is that if we have a graph here, this is a positive gradient. When going from left to right, if the graph goes up, therefore you have a positive gradient. If when going from left to right, the graph goes down, you have a negative gradient. So gradient could be both positive and negative. Next one, the length of a line. The length of a line, length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, right? Notice that you're squaring the difference. So basically it's delta x squared plus delta y squared, okay? So for example, let's say we have the same points as above. We have 1, 4 and 4, 8. Okay, therefore the length of this line would be equal to the square root of 4 minus 1 all squared plus 8 minus 4 all squared. So 4 minus 1 is 3, and 3 squared is 9, plus 8 minus 4 is 4. 4 squared is 16. This is equal to the square root of 25, which is equal to 5. So therefore the length of the line connecting these 2 points has a length of 5 units. Okay, we normally say 5 units if the unit is not known. So this is how you calculate the length of a line. Okay, pretty simple, pretty straightforward. Note, right, an important thing to note is make sure that whatever you use for x2 you also use for y2. Okay, some people sometimes mix it up, and pay careful attention to negative signs. Okay, because some people tend to forget the negative signs. Remember, two negative signs together is a plus, a minus, and a plus is a minus. Okay, and next easy concept, we have the midpoint of a line. The midpoint of a line is a coordinate, right? So it is given by x1 plus x2 all over 2 comma y1 plus y2 all over 2. And the midpoint basically gives you the coordinates of a spot directly in the middle of the line. So again, using the same coordinates as above, we have 1 comma 4 and 4 8. Okay, therefore the midpoint of this of the line connecting these 2 points is equal to 4 plus 1 all over 2 comma 8 plus 4 all over 2. This is equal to 5 over 2 comma 6. Okay, so again, the midpoint of a line basically gives you the point directly in the middle of the line, and it's a simple formula to follow. It gives you a coordinate. Okay, parallel lines now. Two lines are parallel if they have the same gradient. So let's say the gradient of one line is m1 and the gradient of another line is m2. So if two lines are parallel, that means m1. So if parallel, this implies that m1 is equal to m2. Okay, so let's say we have an equation 3y is equal to 2x plus 4. Okay, and let's say we have another line with equation y is equal to 2/3 x plus 1. Okay, are these two lines parallel? So by first instance, you might say the gradient of this line here is 2, the gradient of this line here is 2/3, so they are not equal. But when comparing these things, try to make sure that the coefficient of y is 1. Okay, make sure the coefficient of y is 1. So we want to make y alone the subject of the formula. Okay, so here y is the subject of the formula, so we have y is equal to 2/3 x plus 1. Let's make y the subject. So to make y the subject for this one, we basically divide throughout by 3. So we get y is equal to 2/3 x plus 4 over 3. Okay, and what we could see is that since m1 is equal to m2, these lines are parallel. Okay, if you want to represent parallel lines also, we sometimes use the symbol this. Okay, basically two straight strokes. And that's how we represent parallel lines. The next line, we have a perpendicular lines. Okay, two lines are perpendicular if the product of their gradients is -1. Therefore, if perpendicular, m1 multiplied by m2 is equal to -1. And if two lines are perpendicular, we normally represent them by this symbol. Okay, you'll normally remember this symbol from a triangle. If you have a right angle triangle, you normally see the symbol here. This is how we represent two perpendicular lines. Okay, so let's say now that we have the let's say we have a line which has a gradient of 4/5. Okay, and we want to find the gradient of a line which is perpendicular to that. All we have to do is m1, which is 4/5, multiplied by m2 is equal to -1. Therefore, m2 would be equal to -1 divided by 4/5, which is equal to -5/4. So this is how you find the whether two lines are perpendicular and how to determine the perpendicular line if you know the gradient of one line. Okay, so again, it's all of this is m1 multiplied by m2 is equal to -1, where m1 is the gradient of one line and m2 is the gradient of the other line. If m1 multiplied by m2 is not -1, this means that the lines are not perpendicular. Okay, next thing we come to is something called a perpendicular bisector. Okay, so a perpendicular bisector is a line which is perpendicular and passes through the midpoint. Okay, so a common question is to find the equation of a perpendicular bisector. So actually we'll come back to this one just now. Let's do the equation of a line first. The equation of a line is given by y is equal to mx plus c. Okay, where m is the gradient of the line, which we mentioned before, the gradient which is also the slope, and c is what we call the y-intercept. Okay, the y-intercept. So if we have a line here, okay, and we have a line going through it here, we have our y-axis and x-axis. Okay, this point here is called the y-intercept. Okay, and we give it the symbol c. So if when y is equal to if let's say when y is equal to 5, x is equal to 0, therefore when y is equal to 5, we call that the y-intercept. Okay, so the intercept is the coordinates of the intercept is given by 0 comma c, which is where the constant is, because whenever we put, if we were to sub in x as 0 here, we would get c, because m multiplied by 0 would be 0, so we would therefore get y is equal to c. So m represents the gradient and c represents the y-intercept. Okay, now if you want to find the equation of a line, we have a simple way to do it. All we do is y minus y1 is equal to m into x minus x1. Okay, you leave in y and x as it is by itself. In this, we substitute the value for the gradient. Okay, and then x1, and y1 are coordinates of a point on the line. Okay, so x1 and y1 are coordinates of a point on the line. So let's say, for example, I tell you that the gradient of a line is equal to 5, and it passes through the point 1 comma 5. Okay, therefore what we do in this example is we have y minus 5. Okay, and this 5 here is here, okay, this y1 here is equal to m, which is also 5, multiplied by x minus x1, which is 1. So we get y minus 5 is equal to 5x minus 5. Therefore, y is equal to 5x minus 5 plus 5. When we bring this across, and we therefore get y is equal to 5x. Okay? And what this tells us is that the gradient of this line is 5 and the intercept is 0. What this means is that this line passes through the origin. Okay? So this is how you get the equation of a line. So for this one, okay, let's say I tell you to find the midpoint, to find the line of the, so in this question what it normally asks you is to find the perpendicular bisector, which is basically the equation of the line which is perpendicular and passes through the midpoint. So using our same example as before, 1 comma 4 and 4 comma 8, okay, what we learned is that we found the gradient and the midpoint already from before. Okay, so for this one we found that the gradient of the line was 4 over 3 and the midpoint was 5 over 2 and 6. Okay, so the gradient was 4 over 3 and the midpoint was 5 over 2 comma 6. Okay, and we know this is the gradient of the line and this is the midpoint of the line. So we have the midpoint, but we want to find the gradient of a line perpendicular to it. Okay, so therefore remember we have m1 multiplied by m2 is equal to -1. So if we want to find the gradient of the perpendicular line, we have 4 over 3 multiplied by m2 is equal to -1. Therefore m2 is equal to -1 all over 4 over 3, which is equal to -3 over 4. So therefore the gradient of the perpendicular line is -3 over 4. And using the equation that we found from above, we have y minus y1, in this case y1 is 6, is equal to m, which is -3 over 4, onto x minus x1, which is 5 over 2. So we get y minus 6 is equal to -3 over 4x minus, so it becomes plus. Okay, remember, make note of your minuses. So it becomes plus 15 over 8. Okay, what we get here is y is equal to -3 over 4x plus 15 over 8 plus 6. To make this simple, what we could do is multiply throughout by 8. So we do have fractions. So we'll get 8y is equal to -3 over 4 multiplied by 8. Okay, we get -6x plus 15 plus 8 times 6, which is 48. So therefore we'll get 8y is equal to -6x, okay, plus 8 plus 5, so that'll give us 3, and 4, 5, 6. So we get 8y minus is equal to -6x plus 63. Okay, so the equations for these things, you kind of need to know them for perpendicular, how to know if a line is perpendicular, how to know if a line is parallel. Okay, normally they would ask you to find the equation of the perpendicular bisector, how to find the equation of a line. To find the equation of a line, you need to know how to find the gradient, and you also need to know how to find the y-intercept. If you want to find the y-intercept, just remember that the y-intercept occurs when the value of x is 0. Okay, and that was the end of this video on coordinate geometry. Do look forward to the next video, which would cover questions and If you have any questions or problems, feel free to message me. Thank you.